All right, welcome back. It's a little data preparation for machine learning. All right. But before we get started, hit the like button, subscribe, and share this with anyone you know is taking the AWS Machine Learning Associate exam. All right. When preparing data for machine learning in AWS, you'll encounter four challenges that can make or break your model's success. Think of this as cleaning and organizing your workshop before building something important. The quality of your preparation directly impacts your final results. Handling missing data. All right. Missing data is inevitable in real-world data sets, whether it's from collection errors, system outages, or simply unavailable information. Gaps in your data will mislead your algorithms if left unaddressed. Most machine learning algorithms can't handle missing values automatically, so you need a strategy. Start with the simplest approaches for quick prototypes. You can replace missing numerical values with the mean for normal distributions or median for skewed data. For categorical features, use the most frequent value. While these methods work in one line of code, they ignore relationships between features. They're naive, but useful for getting started. For production systems, leverage machine learning itself to impute missing data. K-nearest neighbors, or KNN, finds similar rows and averages their values, taking advantage of feature relationships. This works well for numerical data, but struggles with categories. For categorical data, consider building a neural network to predict missing values based on other features. It's more complex, but delivers better results. The most advanced technique is MICE, that's multiple imputation by chained equations, which uses iterative regression to fill gaps. It's computationally intensive, but represents the current state-of-the-art methods. In AWS, SageMaker Data Wrangler provides built-in imputation through its user interface, while SageMaker Processing Jobs lets you implement custom approaches while using scikit-learn or your own algorithms. Let's save that one. Oh, there we go. All right. Balancing uneven data. All right. So class imbalance occurs when one outcome dominates your data set. Think fraud detection, where 99.9% of transactions are legitimate. Without addressing this, your model can achieve high accuracy by simply predicting no fraud every time, missing the critical cases you actually care about. You have several strategies available. Oversampling duplicates minority class examples, while undersampling removes majority class rows, risking data loss. SMOTE, or synthetic minority oversampling technique, creates synthetic examples using KNN, and it provides a middle ground. You can also adjust decision thresholds for fraud detection, right? You can lower the threshold to catch more suspicious activity, and it can result in more false positives, but it's necessary. For business critical applications, favor recall over precision. It's often better to flag legitimate transactions as potentially fraudulent than to miss actual fraud. AWS supports this through SageMaker's built-in algorithms like XGBoost, which handles class weights automatically. For SMOTE, implement it in custom training scripts using SageMaker processing. Amazon Fraud Detector is specifically designed for imbalanced data sets in fraud detection scenarios. Let's get a save on this. All right, and outliers. Okay, so outliers are data points that deviate significantly from the norm. They might represent genuine edge cases, like a billionaire's income in a salary survey, or data entry errors. The key question is whether they reflect real patterns or distort your model. Use statistical methods to identify outliers, values beyond 2 to 3 standard deviations from the mean or outside 1.5 times the interquartile range. Amazon's SageMaker random cut force algorithm provides unsupervised anomaly detection, and it's available across SageMaker, Kinesis Data Analytics, and QuickSight. The decision to remove outliers requires domain expertise. Remove them if they distort patterns, like extreme income skewing averages, but keep them if they represent meaningful edge cases, like rare diseases and medical data. Let's get a save on that. Okay. Okay. Transforming features. So raw data rarely comes in the format your model needs, right? You'll need to transform, encode, and scale features to highlight patterns and ensure fair treatment across different data types. Binning groups continuous binning groups continuous variables into discrete buckets, right? So this is converting ages into ranges. So think like 0 to 10, 11 through 20, etc. So this reduces noise, but can discard useful granularity. So use it careful. Quantile binning ensures equal distribution per bin. Mathematical transformations reveal hidden patterns, Log transformations linearize exponential growth, while square roots handle sublinear relationships. Think YouTube's recommendation system, right? It famously uses logs, right? So hours since last watch as a feature. Okay. Categorical data needs encoding for numerical algorithms. One hot encoding creates binary vectors for each category. This is essential for classification models. Scaling equalizes feature influence when you have different units, income versus age. You can use a min-max scalar for a 0 to 1 range, or a standard scalar when you mean for mean equals 0 and the standard deviation equals 1. Within this, AWS Data Wrangler will provide visual tools for all these transformations. For custom logic, SageMaker processing jobs can run scikit-learn, that's SCIKIT, learn, preprocessing at scale. All right, we'll save that. Okay, so let's get a little more. This is the anomaly detection. Oh, we already went through that. Oh, no, we didn't go through that. All right, all right, SageMaker Unified. Okay, so SageMaker Data Wrangler, this is your production. This serves as your pre-processing command center, connected to S3, Redshift, or Athena. Then apply transformations through a visual interface, handle missing values with built-in functions, resample classes for balance, detect anomalies with random cut force, and apply encoding and scaling, all without writing code. For production pipelines, export your data wrangler flow to SageMaker processing jobs or integrate directly with SageMaker pipelines. This ensures your pre-processing steps are reproducible and scalable. Remember that AWS has rebranded SageMaker to SageMaker AI as of 2025, though the underlying functionality remains the same. The key to successful data prep is understanding that these techniques work together. You might impute missing values, balance classes with SMOTE, remove outliers using random cut forest, and then apply scaling and encoding, each step building on the previous one to create clean, machine learning ready data that your algorithms can actually learn from. That concludes this section, and we'll get started shortly with an overview of SageMaker AI. But thank you for contacting and listening, and hit the like button, subscribe, and share with anyone who's going to be taking the AWS Machine Learning Associate exam. All right. Thank you, and have a good day.